Hello and welcome. I'm your Professor Steve Wallen. Let's go ahead and get started on Chapter 2 homework help, shall we? Alright. Chapter 2 homework help. Right here in McGraw-Hill, Chapter 2. Let's actually go in as a student, shall we? Student view. And there we go. Now it'll access it. Perfect. Yep. We're gonna go do this. Let's get it done. Alright, here's a production possibility curve. Now if you look at this curve, one thing to notice is we have investment goods on the left, consumer goods on the right. So consumer goods are things that we consume and use. So it could be food, it's not going to be too durable usually. I mean, sometimes they're durable. The biggest thing is that a consumer good doesn't produce more consumer goods, okay? Investment goods allow us to produce more in the future, okay? So for example, roads, infrastructure, those would help us produce more in the future. Factories, those would help us produce more in the future. They're goods, investment goods are any goods that we make to help us produce more goods in the future. Consumer goods are just an end product value, okay? So investment goods are going to be more for the future. They're going to help us build more in the future. Again, consumer goods down here, that's for right now, things we want to enjoy now and have, okay? So what is the opportunity cost of increasing investment goods from 6 to 8 units? Okay, so let's come up here. Let's take a look at this. Grab our pen. What color should we choose? We're gonna go this pinkish color. Okay. So it says, what is the opportunity cost of increasing investment from 6 to 8 units? So we go over here to 6. So let's say we're at this magic point here. Okay. Yep, that lines up. That should be at 6 right there. So we check it. Yep, that lines up at 6. Okay. Sometimes it's hard on these graphs, so you might want to just kind of look real quick and make sure you're actually choosing the right point. And it says, what is the cost of increasing investment from 6 to 8 units? So we're going to go up here to 7, 8. So this is where we're going to end up. This is our first point. This is our second point. This is what we're going to. And we're increasing investment. So investment's going up. Okay? Now when we do that, what happens to consumer goods? Well, we draw this line down here. Okay, so we started out at 6 consumer goods, and we're going to go down to 3. So that's our opportunity cost. If we're going to look more towards the future and increase investment, then meanwhile, in the short term, we're not going to have as much consumer goods because we're using those resources to produce future things and to expand our curve, our possibility curve. Because what happens if you increase factories, increase infrastructure, increase technology, this entire curve will move out. This entire curve will move out if you're going up here, but it's going to take time to do so. So in the short run, you're going to be gone. You're going to be losing, foregoing some consumer goods. But in the long run, you're going to actually extend this possibility curve. So then you can start producing on a curve that's like out here. Okay? Don't you love how beautiful these arrows look? It's amazing what things look like when you draw them with a mouse. All right, so let's take a look down here. Let's go back to our regular pointer. What is the opportunity cost of increasing investment from 6 to 8 units? Okay, well, first drop down, I'm going to be losing consumer goods because of investments going up. Then I'm going to be losing consumer goods. It's a trade-off there. And then right here, they just want me to type it in. Let's go ahead and try it out. So we're going from 6 to 3, so then we're losing 3. And then what should you always do? Check it. Check and see where you're at. Okay, let's go over here, check my work. Actually line that up. Actually doesn't line up as well, but as we can see, we did that correctly. All right, perfect. We're looking good. Always get in the habit of checking your work. That way you don't do too much and it not work. Let's clear that. Kind of messy. Okay, what will happen to future production possibilities if investment increases now? Okay, so if we go more towards this investment over here, investment goods, what will happen? Well, production possibility will take some time. Think about it. If we're putting in more factories, more roads, more technology, what will we be able to do in the future? We'll be able to produce more of anything, right? So it's going to increase. Okay. What will happen to future production possibilities if only consumer goods are produced now? So if we go over here and we produce only consumer goods, what will happen? Okay. That's interesting. It says increase, decrease, stay the same. Now, this is where it gets tricky. Would it decrease or stay the same? Now, I want you to think about what happens to factories, what happens to roads if you don't put money into them. Do they stay the same? No, they degrade, right? Things get destroyed. And so actually, you could see a decrease. Let's check my work and see what happens. Yep, all correct. We're good to move on. So remember, if you do all consumer goods, you actually have to put a level, what we call maintenance investments. If you don't put at least enough to maintain your public works, you don't have enough to maintain your factories, then you'll actually see this curve right here. It'll go down, it'll go backwards. Okay, and that does happen in some countries. All right, let's go ahead and move on. We'll clear the screen. That was question 1. Question 2. Ooh, we got a lot of math here. All right, don't be scared. I'm going to walk you through it, okay? Suppose the following data describes output in 2 different years. So we have year 1. Remember, year 1 is your first year, so that's going to be a base year. That's what we're looking at to judge everything off of. Year 2 is the next year. So we're going to be comparing these years and seeing how they produce. So right here we have some items. They're using just apples, bicycles, and movie rentals, okay? And in each year, what can we see? We can see right here. Let me go ahead and get this so you guys can see a little bit better. In each year, okay, we have different units being produced. In addition, we come over here. Also, what else is different? The prices. So how can I really compare year 1 and year 2 here? I mean, in order to compare them, you have to use the same price structure to get a real comparison. We're going to do a nominal first. It has to do a nominal. And then people think, oh, our economy is doing great. But it's only when you actually set the prices the same on both years do you get a real GDP. And you're going to get real price comparison. Remember, GDP is gross domestic product. Nominal means they just do it based on whatever numbers they're given. Real means they adjust for inflation or price changes. And that way you're actually comparing apples to apples, which conveniently enough, there we go. We actually have apples here. Okay, so let's take a look at this. Compute nominal GDP in each year. So nominal, all you're going to do when you come over here, you're going to take this right here and you times it by this, because that means we have 20,000 apples by 25 cents. And then you just add them up, okay? You add them up and then we're going to get our nominal. So you take this times this and then this times this. So let's go ahead and do that. Let's pull up a quick calculator, shall we? Okay. So 20,000. Get our cursor back. 20,000 times, and this is the one where a lot of people make a mistake. This is a cent sign here. 25 cents. Okay. So that's gonna. It's not a dollar sign. So you're gonna go 0.25 equals 5,000. So in the first year, there's $5,000 worth of apples being produced, okay? So let's come over here. Let's write that down, shall we? 5,000. Boom. Isn't that pretty? 5,000. All right. Now, let's come over here. We're going to go back to cursor. So 700 times 800. Okay? 700 times 800. We go equals. Whoa, that was a lot. So is a lot of this, their economies, if these were the only 3 being measured based on bicycles, yeah, a lot of it's going to be based on bicycles. We got 560,000. So let's come over here. Write this down. So now we got 5, 6, 0, 0, 0, 0. So beautiful. It's so amazing how things look when you draw it with a mouse. All right, here we go. Next one, last one for year. Remember, this is going to be what? This is year 1, and we're just doing nominal. Okay, this is just nominal GDP. So the nominal. All right. 10,000 times 1. I'm not even going to put this in the calculator. What's 10,000 times 1? 10,000. All right, there we go. However, some of you still might put it in the calculator, and that's okay. Not a problem with that. Then we would add all this up. So 560,000 plus 10,000 plus 5,000. So let's go 560. So that's going to be 570. 575. Okay. Oh man, it's like a caveman did this math. It's pretty advanced caveman going on. Look at that. 575. All right. So we put it in. We want to see if we got it right. Here comes the moment of truth. Go over here. 575 0 0 0. And then if we do it right, what does that mean? That means we're going to be good. All right. Check my work. Boom. Correct. Get in the habit of doing this. Okay. Close this out. We'll go back till this is all lined up where it should be. All right. Now, get our calculator back. Let's do the next year. Okay. So for year 2, it's the same process, except we're going to use year 2 quantities and year 2 values. And this is going to give us the nominal for year 2. Okay. So there's year 1. We'll do year 2 in blue. All right. That way you guys can see it. All right. So 30,000 times that. So we just go 30,000 apples. And these apples, because it's year 2 and there's been inflation, are now 30 cents. Oh, sorry. Hear that. Times 0.3. 9,000. So we're spending 9,000 for those. Year 2. That's how much that's going to be worth. Okay. Now we come over here. We're going to go 650. 650 times 900. Okay, so give us 585. 585, and this is in thousands. There we go, and these are all going to be added together. All right, last one. 12,000. I'm going to times it by right over there. 1.5 gives me 18,000. All right, then we're going to add all this up. 18,000. Okay, let's go ahead and add this all up, shall we? So we go 9,000, or we'll just start with 18,000. We got 18,000 plugged in here. We're going to go plus 585 0 0 0 plus 9,000 equals 612,000. Let's put it in, see if we did it right. Even I can make mistakes. Let's see. Let's see what's going to happen. And it's happy. We did it. Good job. All right. Put this back up here. That doesn't want to line up anymore. I'll just clear it all off. All right. By what percentage did nominal GDP change between year 1 and year 2? So let's take a look at this real quick. So this one we ended up with 612. 575, okay. By what percentage did nominal GDP change between year 1 and year 2? Look, right here it gives you the formula. Use the percentage change formula. So we gotta get our new value, which is this, minus the original value, and then we just divide it by the original value. That's all we do. So let's do that with the calculator real quick, shall we? So take 612. We're gonna minus the original value, which is gonna be 575 0 0 0. So the difference between the two is 37,000, and then you're just dividing it by the original value because that's giving you a comparison. That's what a ratio is. That's what the division symbol does. And so if we divide this by 575,000 equals, ooh, big long number. What's this number mean? Well, locate your decimal point. 0.06. And then you got a 4 on there, but it's going to round it. So this is going to be 6%. They probably want the number here. Oh no, they just want increased, decreased. Okay. So obviously it increased by 6%. Let's see if it accepts percents, or we just got to put in 0.06. Let's see what happens here. Ooh. 1 decimal place required. So it's going to 0.4. Let's see if it's happy with that. Because remember, it had 0.4 on the calculator. If we go back to the calculator here, you move the decimal place 2 points, and that gives you your percentage, so it'd be 6.4%. Check my work. And it's still happy with us. We're doing a good job, everybody. We're doing it. Getting it done. It's working. All right. Now compute real GDP. This is what matters, okay? This is the most important GDP because this actually tells you what's really going on, okay? Everything we've done so far is a lot of times what a politician will bring up to say, oh, look, our economy is growing. Real GDP is the only thing that matters, okay? Now compute real GDP in year 2 by using the prices of year 1. Okay, so before, let's go ahead and clear all this out, shall we? Actually, we can leave this. We'll leave this right here. That way you can see the difference. So basically what's going on is before, each of them use their own things, right? But the problem is their prices are different. Can you really compare them truly if their prices are different? No. You have to compare apples to apples, bicycles to bicycles, movie rentals to movie rentals. If you're changing prices from year to year, you're not getting a true comparison. So what we're going to do is we're going to use this year as our base year, right here, and we're going to apply it to both sets to give us a real GDP, okay? To look at what's really going on. So we already did year 1 using this, so this side's already done. We got a check mark here, done. But this side we still got to do, okay? And we're going to use these prices with year 2 and then see what really happened, okay? This gives us the real story. So, and I'll just do it right here below. I'll do it below. So this is nominal. And that's the nom. And we're going to get real down here. We're going to get real as far as what really happened. Oh man, it is hard to write with a mouse. Okay. It's like Picasso over here. I promise. It's beautiful. All right. Let's do this. Clear out all this. Get back to a cursor. Okay, so 30,000 times 25 cents. There's definitely an increase in apples, so we're going to see an increase there. So 30,000 times 0.25, 7,500. Okay, so let's write that down, shall we? 7,500. So already compared to year 1, what do we see has gone up in value? Well, it used to be 5,000, now it's 7,500. We're using the same prices, so as far as apples go, there is an increase here in year 2. Okay, year 2 actually has an increase here. And this is the year 2. Yeah, it doesn't really look too good. There we go, year 2. All right, let's do the next one. Clear this out. 650. And then this time we're only going to times it by 800 because we're using year 1 prices. 520,000. That's a big difference from the nominal, right? Nominal was 585, now we're at 520,000. Okay, let's go 520,000. Boom. Remember, we're gonna be adding these all up. That'll get plus. Wow, that's a big difference. That's a big drop, huh? Before, it looked like we were going up, right? There is 560 to 585. But once we put it in real numbers, though, it actually went down on bicycles, okay? Went down on bicycles. Let's do the next one, shall we? This next one will be easy because it's just 12,000 times $1, so I'm just going to write it on. I could put it in the calculator, but it's just $1. We're not, I'm going to save some time, so there's 12,000. All right, then we add all this up. So 520,000. Give me my calculator back. Tricky. Plus 7500 plus 12,000. I think it's nice that you can actually keep your numbers here and you can see what you got. This is just the calculator that just came on Windows, so but you can just download a calculator app if you need. They're all over the place. So right now we're at 539,500. What do we see is the difference if we use this number compared to this number? They actually went down when on real GDP. So before it looked good. Before, like, oh, we're growing. No. You had inflation. The economy didn't actually grow. So real GDP. Now compute real GDP in year 2 by using the prices of year 1. So let's go ahead and put that in, shall we? Go over here. Give me back my calculator. Let me write this down. Sometimes it disappears on me. It's actually 539 500. There we go. All right. 539,500. All right. And double check your just check your work after each one. It takes like 2 seconds. That way you don't constantly do a boatload of these wrong. Still looking good. All right, come back up here. By what percentage did real GDP increase between year 1 and year 2? Use the percentage change formula. So we're going to do the exact same thing we did before. All we do is we take the difference between both of these, and then we divide it by the original. So we're going to go up to get our calculator out again. So, and let's see, I'm going to go ahead and minus 575,000. So we're at negative 35,500, and we'll divide this by our original total. So we're going down basically 6.1%. So it decreased by 6.1. Let's make sure it's what the calculator said. Whoa, sorry, that was the OBS recording app. There we go. You guys gotta go a little time travel there. You gotta see all the infinite windows. Alright. Calculator. Okay, all you do is move the decimal point 2 places. That gives you the percentage. Or you can times it by 100. That'll also give you the percentage, so it's 6.1. So let's check it. Sorry, it's getting a bit messy. And we got all green, so we're good to go, and we will clear off this mess. Okay, good job, everybody. We're now on to the third problem. Dun 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 dun. Third problem. Here we go. What do we got? GDP per capita in the United States was approximately 55,000 in 2015. Use the growth formula to answer the following questions. What will it be in the year 2020 if GDP per capita grows by 0% per year. So let's go ahead and mark some key things we're seeing here, okay? First off, they're using 2015, and they're using 2020 here. So that's going to be 5 years, okay? 5Y, 5 years. We're starting with 55,000, okay? 55,000. Now, most of you probably already know what this one is, but it's good to write it out because when you get ones that are similar, okay? So, what will it be in the year 2020 if GDP per capita grows by 0% per year? If we're growing by 0% per year, do we have to do anything? No, we can just say straight up what it's going to be. Just go over here. It's going to be 55,000. All right. And then check your work. This is pretty simple math. Yep, we did it. But now, something's going to actually change. What will it be in the year 2020 if GDP per capita grows by 2% per year? All right, so this is where we have to use the formula they have here. They literally give you the formula right here. Growth formula, future value equals present value times 1 times plus the rate raised by t. Okay, so what I'm going to do is I'm going to come over here. What's our rate? Our rate's 2%. 2% can also be written as 1.02 as a whole number. Or not a whole number because it's technically got decimals in it, but it has a decimal number with decimals. But it's not a percentage at that point. If it's a percentage, I'd write it as 0.02 and you'd see a percent sign on it. So the more you know. All right. Nope. No. Give me my 2 back. Give me my 2. Fine, I'll just redraw this. All right. And so that gives us that 1 plus the rate. Okay, so that's going to be 1.02. Right here we have it raised to time, which is how many times it's going to be going up by, which is 5. So we're going to need to get our calculator out. Notice I have a scientific calculator here. So I'm going to go ahead and I'm going to go 1.02. And I'm going to use this feature over here, x to the y. That's how many times I want to raise it by. It gives you a little caret symbol here. So it's going to times itself, because it's going to be multiplying itself several times over. It's going to, each year it's going to go 1.02, 1.02, 1.02, 1.02, 1.02. It's going to do that 5 times. Because we're doing it for 5 years. So our real rate is 1.104. That's our real rate, okay? And then all we do is times this by our current value, which is 55,000. Now we're at 60,724. 60,724. So let me go ahead and draw this out for you guys so you guys can actually see what I did on the calculator. So did that. And then that ended up equaling. Let's go back and see what we got there. Yeah, so you get your number there, and then you're going to times that by the 55, and then you get the number we ended up with. So it's pretty straightforward on that. That's all you have to do. So let's go ahead and check this, shall we? Yep, we got it right. Perfect, we're good. And just to make sure everyone's clear on it, so you take your 10.02. Usually it's just the 1, but because we have to add in the rate's what, 2%, so that's 0.02 in decimal format, okay? And then just do this one more time, raise to the 5th. Just gonna do it 5 times to itself. So that would be 1.104, and all you do is times that by the original value. So which in this case was 55,000. So that's it. And then that gave you that number over there. That's it for question 3. Let's go ahead and clear off all this stuff, shall we? Get our cursor back. We're almost there. We're on question 4. Now this one's a bit longer than some of the homework, so we'll get through it. This goes quick though. All right, gives you an equation. Total output equals number of workers times productivity, which is pretty simple. We got how effective our workers are versus how many workers. That's how much we're going to get out of a system. Okay, so either you need a lot of workers or a lot of very efficient workers to get a high number, or if you have both, you're going to get a really high number. Okay, so if the workforce is growing by 1% a year, but productivity doesn't move, how fast can output increase? Okay, so it says the workforce goes by 1%. So if we go up here, we had and this is if we have 100 workers and they produce $100 total. All of a sudden we now have, instead of 100 workers, we now have 101, and our productivity stays the same. We're still producing $100. So really the only thing that's going to change here is it's just going to go up by 1%. That's it. That's the only change we have. We have this 1% change that's going to go on here. Is it doing it in a percent? Let's make sure. Okay, yeah, it is converting to a percent. If it puts a percent there, then you don't have to figure out what it's actually producing. If you want to figure out what it's actually producing, then you'd come over here to your calculator, or you could just work out the math yourself. This is going to be a 1% change, but with they wanted to know a unit change. We just go 100 times 100 was our original, so they were producing 10,000 to begin with if they were doing units. If you're lucky, we don't have to do, but this is if you had to. This is how you'd do it. Gives you 10,000 there. And the other one, it's going to be 101 times 100 equals 10,100. And then when you compare these two, we can actually prove that it was a 1% gain, because we have 10,000, 10,100. What's the difference? The difference is 100 between the two, right? And then you divide it by the original, which is 10,000. 0.01, which as a percentage is 1%. We've now double checked it. That's our math right there. So if you want to, you can actually just times out everything, and you can get the actual information and you just compare it to the originals, whatever the difference is compared by the original. So here, I can see the difference is 100, and then I divide that by the original, which is 10,000. And lo and behold, that gave me the 0.01, which if I move the decimal point is equal to 1%. Easy peasy. We got a little bit more to do. All right. If productivity increases by 3% and the number of workers increases by 1% a year, how fast will output grow? Because the workers and the output is the same number, you can literally just add up the percent points, and it should just be 4%. However, if you're starting with different numbers of workers and different numbers of output here, these percents will change it a bit. So, because in other words, sometimes it's not going to add up nice sometimes. So let's go 4. Yeah. All right, let's see if we're right. We are correct. There we go. That one's fairly simple. We'll clear off all this. Clear screen. Last one. We're almost done. We're almost done. Hang with me. Oh no, we got some numbers. We got numbers. What are we going to do with this? Okay. This is income groups. Highest fifth, second fifth, third fifth, fourth fifth, lower fifth. So this is basically taking the U.S., okay? It should label United States up here, but they don't, but they put it in the question. What is the average income in the United States? So we took the U.S. and split everybody up into income groups. This is what they would fall into, okay? So the highest fifth of the U.S., the highest fifth income earners, are making above $112,000, and their average income is $194,000. Okay, so that's the top fifth earners as far as income. And the share of total income, basically that 20% gets 50% of the income. The second fifth is interesting. They're about 20% of the population, and they get about 20% of the income. Okay, they're pretty close. The third, it's a little bit farther away because you're like 6 percentage points away from being 20%. So this one's looking pretty bad. This one, you're 20% of the people are at 8% of the income. This one, 20% of the people in the U.S. are surviving at only 3% of the income gains. Okay, so this one is definitely the poverty level. It's below 21,000. You're making less than 11,000 a year. Okay, so what are they asking us? What is the average income in the United States? Well, if we know this is an average income for 20%, this is an average income for 20% of the people. This is for 20, this is for 20, this is for 20. I can just add all of these up and then divide by 1, 2, 3, 4, 5, and that'll give me the average income of the U.S. So let's do that, shall we? Let's get our calculator back. Clear this out. 194,053, and we're going to plus 87834 plus 54041. See, I love this because it keeps the running total, so then I can see if I put things in right and I can double check my math. 31 plus, or nope, I gotta do 087, then plus it, and then 1167. So now, as you can see, I got all 5 of those numbers here. Gives me a grand total of 378.69, and I have to divide it by 1, 2, 3, 4, 5, and I can do that because these are even groups. They have equal population in them. Okay. So we will divide by 5 equals 75,003. Let's write that down, shall we? So this is the average income. Remember, this is average, not median. Median is a much better thing. When we look at this, we're thinking America's doing pretty good because it's an average income. The problem is extremely high people can affect the average and extremely low people can affect the average. In this case, with 51%, we can see there's a very huge skew on this 20th percentile at the top. So people are thinking, oh yeah, America's doing great, when really, well, we have 20% of our people living off of this. So, all right, what is the average income in the United States? 75,738. But it should be noted that there are some people that make sense to be here, like college students and stuff like that. Like, you're going through school, like sometimes you're not really earning much because you're going to school. So, let's see, 0.2. Let's see if it requires 0.2 in there. It just rounds it off. Double check. We're almost there, don't worry, we're almost through with the homework. Boom, we got it. Got it right. Okay. And then come over here. What percentage of the average income of people in the highest fifth would have to be taxed away to bring them down to that average? Okay. So all we do with this is, let's take this out. We're going to use this number right here. That's what they average out to. And we're just going to find out how much we got to minus to bring that down. So take 194,053. So pretty. All right, just bring this on the calculator real quick. So we'll just go ahead and go minus. I can always reverse signs as well if it's faster. My cursor back. I'll just reverse signs. 194,053. Alright, so let's write that down. So I would have to tax them at an amount that would take out 118,000 from them. 314. That's what I'd have to be able to, that's what I have to take away to get this number to that number. So right here is what I'd have to take away. If I take 194,053 and I take away this amount, I end up with that. Okay? And it wants it in a percentage. So what percentage of the average income of people in the highest fifth would have to be taxed away to bring them down to that average? So we need to find out what percentage is this compared to that. So we take this, we're going to divide it by the original, 194,053. So we're getting a 0.609, which if we convert this to a percent would be 60.9%. So let's go ahead and pop that in, shall we? If we did it right, we'll see 60.9. Are we right? Moment of truth, last problem. We are correct. And that looks like a pair of sunglasses. I like that. All right, means we're seeing clearly. We're doing the math clearly. We're doing good. You made it. All right, that is Chapter 2 homework help. Thank you all for being here. Let me clear away all this mess. Hopefully you guys are enjoying economics. Hopefully this helps out a lot as far as doing homework, having someone walk you through it, and then being able to watch it on your own pace. I look forward to seeing you all in class, and hopefully you guys are having a great day. All right, you all take care.